Welcome to the Deep Dive, your shortcut to getting quickly up to speed. Today we're jumping into something pretty fascinating, where finance meets cutting-edge tech. We're looking at how you can recover and really understand trading algorithms, those expert advisors or EAs, even if you only have the compiled code. And AI plays a huge part.
Right. It's a situation lots of traders find themselves in.
Right.
You've got this EA, maybe it's performing great, but, well, the source code, lost. Or
Yeah.
maybe you never had it. So how do you figure out what's actually going on inside, how it makes trades? That's what we're digging into, cracking open that black box.
Okay, let's unpack that. So you've got this compiled file, the EA, but it's sealed, right? You can't just open it up and see the strategy logic. And trying to reverse engineer it manually, I mean, that sounds incredibly difficult, not to mention expensive.
Oh, it absolutely is.
Yeah.
Traditionally, yeah, very time-consuming, very costly.
Yeah.
But that's where something like an EA reverse engineering service comes in. It automates that whole decompilation process,
Yeah.
uses advanced techniques to pull the logic out without needing a human to manually rewrite code.
Automates it, so it's faster. And probably more consistent, too.
Exactly. Speed and consistency are key, and it means you get reliable results without the huge price tag of manual reconstruction. Plus, no manual changes means it's secure for you.
Okay, so you run this service on the compiled EA. What do you actually get back? Is it like one big confusing file?
No, you get a few things, like a blueprint. First, there's the disassembled assembly code, the ASM. That's very low level, the raw instructions. But crucially, you also get decompiled C-like pseudocode. This is much, much closer to human-readable code. You can actually start to see the decision-making, the function calls, how it manages risk.
A C like pseudocode, so it looks a bit like C programming language.
Pretty much, yeah.
Yeah.
It captures the control flow, the logic, in a way that's far easier to understand than raw assembly.
And I heard there are optional things, too, for like a deeper dive.
That's right. You can get things like a rich ASM listing, basically, the assembly code, but heavily annotated, making it much quicker to analyze if you need that level of detail. And then there's the logic reconstructed file. Think of that as a really high-level structured map of the EA's entire strategy, like the decompiler's best guess at the original blueprint.
Wow, okay. That's already quite something. But you mentioned AI earlier. Where does artificial intelligence fit into this picture? This is where it gets really interesting, right?
Absolutely. This is the game changer. Those files we just talked about, the ASM and especially the C-like pseudocode, they aren't just for human eyes. They are specifically generated to be fed into AI models.
Ah, I see. So the reverse engineering creates the input for the AI.
Precisely. You can take these outputs and use powerful, state-of-the-art AI models. Think things like Gemini 2.5 PRO, which you can access through Google AI Studio, often for free. You give the AI the assembly, the pseudocode, and any known input parameters for the EA. Then you prompt it, you ask it to reconstruct the original source code based on that information.
And does the specific AI model make a big difference? Like, is Gemini 2.5 PRO significantly better than others?
It can, yeah. The more advanced the model, and crucially, the larger its context window, that's how much information it can kind of hold in its head at once, the better it generally is. There are larger context windows and better code understanding, like you find in models such as Gemini 2.5 PRO, help it piece together more complex EAs accurately. It might outperform something like O4 Mini, even if that one's also capable, just because of that deeper grasp of complex code structures.
Okay, that makes sense. So walk me through it practically. If someone listening wants to do this, what are the steps?
Well, it's pretty straightforward, actually. Step 1, use the reverse engineering service on your compiled EA file to get the ASM and pseudocode outputs. Step 2, craft a good prompt for your chosen AI model, explaining what you have and what you want it to do, reconstruct the source code. Step 3, upload those files to the AI, run the prompt, and then step 4, review and refine the code the AI generates. It might need some tweaking, but it gets you most of the way there.
So let's bring it back to the listener. What's the real benefit for you as a trader or maybe a developer who's lost their code?
The biggest benefit is full trading logic recovery. You can potentially get back a complete working strategy you thought was gone forever. Or maybe you have an EA, but you bought it and you want to audit it, understand exactly how it works, find hidden risks, or just confirm it does what it claims. You get really deep strategy insights.
And you mentioned cost earlier, compared to that $10,000 figure for manual work.
Oh, it's way more efficient. The reverse engineering service to get the AI-ready files might only cost a few $100s. Then you use the AI, which might even be free depending on the platform. It puts powerful analysis and recovery within reach, making it much more time and cost-effective.
So wrapping this up, what's the big takeaway here? This AI-powered decompilation sounds like a pretty major shift.
It really is. We're seeing a way to turn this opaque compiled code back into understandable logic using AI. It's transforming how we can audit, understand, and even restore complex trading algorithms. And it makes you wonder, doesn't it? If this works so well for trading EAs, think about other areas. Could this approach help us understand or recover functionality from any compiled software where the source code is lost? Maybe old games, legacy business software. It really opens up some interesting possibilities for the future.